Hello, ladies and gentlemen, and welcome to our webinar. Today, we will discuss the common challenges and pitfalls one may end up with when running distributed NoSQL databases at scale. We are going to have a nice chat, me and Guilherme, over the considerations you need to be aware of when testing, deploying, and maintaining your workload at scale. All right? Before we get started, let's quickly introduce ourselves. My name is Felipe, and I am a solution architect at ScyllaDB. I live in Brazil, and I have a 2-year-old puppy, which I love more than anything, even more than you, Guilherme, just so you know. Nice to meet you all. And along with me, I also have my fellow countryman, Guilherme. And once again, thank you so much for being here. And today we are going to have this nice and friendly chat, as well as presenting a demo that Guilherme prepared specifically for you. So Gui, welcome. Thanks again for being here. And do you mind please introducing yourself?
For sure. And hey, everyone, my name is Guilherme. I'm also solutions architect here at ScyllaDB. As Felipe, I also live in Brazil, and I'm a technology enthusiast who likes to experiment with open source technology and open source gadgets. I'm also interested in gaming on Linux and database at scale. As Felipe mentioned, I have a puppy that is 4 months old now, and she's currently at the doggy daycare, but she's probably having a blast of a day. It's awesome to meet you all and have you here. Felipe, back to you.
Thanks, Gay. Interestingly enough, I mean, gaming in Linux, that could be alone its own webinar. I definitely should
Absolutely.
get some tips from you. But yeah, I mean, with that, let's get moving. Let's quickly have a quick intro about what ScyllaDB is. We are the team behind ScyllaDB, the database built for game changers. And in 2020, ScyllaDB has been awarded InfoWords Technology of the Year. And this was primarily due to the fact that the main proposition of ScyllaDB is to resolve the challenges commonly encountered with other NoSQL database solutions. For example, from a technical perspective, the primary reasons most of our users choose ScyllaDB is given the fact that it is able to deliver high throughput, provide lower latency response times when compared to our competitors, and 3, all that while reducing the total cost of ownership when compared to other solutions. Now, ScyllaDB was built with a close-to-the-metal design architecture that squeezes every possible ounce of performance out of modern infrastructure. This translates to predictable low latency, even at high throughputs. Now, with such consistent innovation, the adoption of our database technology has kept growing over the years, and today we have over 400 key players worldwide. Now, these are some of the many game changers currently leveraging ScyllaDB for their use cases and for their deployments. And I personally find this listing very interesting. I just saw someone saying that the reason why you are here is because you saw Discord history. So yes, Discord is here, but not just Discord. I mean, many other companies such as EA Games spoke about how he likes playing games on Linux. EA is here, Epic Games as well, who is using us to power their Unreal Engine derived data cloud. Other social networks such as ShareChat, media streaming such as Disney Plus, Hotstar, Hulu, and so on. All right. So in case you don't know it yet, please talk to us so we can understand how ScyllaDB can help you and whether ScyllaDB may be a good fit for you. All right. All that said, let's get started. So what we are going to essentially be doing today is Guilherme will show us a workload delivering close to 1 million operations per second, and with single-digit millisecond response times on top of ScyllaDB. But Before we actually get to that part, the actual demo Guilherme built, here's a question for you, Gui. And I actually did the math, just so you know. So I actually have those notes written here to ensure I don't get those numbers wrong. But the question is 1 million operations per second, or 60 million operations per minute, or 3.6 billion operations an hour, or roughly 86 billion operations a day. What does that mean?
Yeah, Felipe, for sure, 86 billion operations a day really seems like an impressive number. However, when you break it down by hour, minute, and second, it starts to become a reasonable range of operations. For instance, 1 million operations per second might also be like a massive amount of operations. But for distributed system, this whole workload will be processed by multiple workers. In CLDB's case, those workers are called shards, which are CPUs that compose your cluster. On a well-built Scylla cluster, you can deliver the 1 million operations per second because every shard will be actually performing a subset of the number of operations. To the cluster that I'll demonstrate later today does exactly that. It is composed of just 3 instances of the i4i4x large family, so 48 vCPUs overall. And in that setting, every vCPU will be doing roughly 30,000 operations per second. Now, that doesn't sound like a
Wow.
lot, does it? That's the power of a distributed system, and in this case, CLDB, as it's built to be linearly scaled as you add more processing power to the cluster, while taking full advantage of the hardware that it's deployed on. So, Felipe, does the 86 billion operations a day number looks less scary now?
No, yeah, it definitely makes sense what you explained. 30,000 operations per shard or per CPU, it makes more sense now. Yeah. So if I understood you correctly, the power of the 3 instances you are going to demonstrate us combined are what makes the cluster capable of achieving such a high throughput. However, just makes me wonder. Hardware fails, right? Split brain situations may happen on the networking level. What are some of the considerations you, as an architect, would recommend to our users when they are coming up with their cluster topology, their deployment, and so on? And does it mean that the failure of a single node, for example, will be enough for ScyllaDB to be unable to achieve our promise, or well, we are promised 1 million operations per second?
Sure, so CLDB is designed to be highly available and very resilient to failures, both from the hardware and network levels. So the loss of a single node will not impact cluster operations, nor it should impact throughput. When setting up a cluster, you should always plan for high availability by using multiple availability zones to compose that cluster based on your application factor. If you're using the replication factor of 3, which is the default, the recommended one, then you should pick 3 availability zones, for instance. CLDB Rack Awareness automatically distributes data along the existing AZs that will ensure high availability, even in the case of a complete zone failure. So the cluster continues to operate normally, even under that catastrophic situation. The recommended replication factor of 3, and also the choice of the consistency level, can make or break the availability of a cluster in the event of an outage. So we always recommend using replication factor of 3 and consistency level quorum, or at least local quorum. So in the case that a complete zone failure, your queries can still operate in a consistent manner, and when service is restored, the data will be replicated to joining nodes to restore the service automatically. Applying best practices such as the zone deployment is crucial to the functionality of a cluster in extreme situations. So make sure that you follow Scylla's great documentation on choices when setting up your cluster for maximum availability and for maximum resiliency. And in general, you should always follow all best practices throughout the testing to ensure that you maximize your chance of success, Felipe.
Thanks. No, I particularly like the recommendation of using the docs. So if you're getting started with ScyllaDB, our docs are a great way to get started and to understand how things work. The URL is docs.scylladb.com. And as Guy said, it's very, very, very extensive. Here's another question to you. So because my previous questions have been a bit technically, but let's switch now from to a business perspective, and also from your own experience working with a variety of customers and use cases. I think that the 1 million operations per second number is definitely an impressive one. Uh, which kinds of use cases require such high throughput? Certainly, the first one that comes to my mind would be a real-time one, such as Twitter, for example, right? We can easily reason about many users liking tweets and posting, etc. Any others that you could leverage and reason about?
Sure. So many use cases require that level of throughput. A busy ad bidding service or IoT data collection or analytics platform, real-time chat, as you mentioned. So today's industries have the needs that go beyond traditional database can offer. So especially in cases where it's more than a single server can deliver. And that's why computing at that scale can only be achieved by a distributed database, especially the ones that are focused on providing high throughput, low latency at scale, such as ScyllaDB. Industry leaders are seeking ways of expanding and deepening the analysis of the existing data and enriching the decision from analytics insights. And that's easy to understand why use cases can easily reach or even surpass the million of operations per second level. So think of a streaming services case of watch history. It can be used for different
Mm-hmm.
purposes to display the last watch programs that allow users to resume what they had stopped, also to display a list of titles that are still in progress, and to enrich the user experience by using all of the data to recommend relevant titles so the user keeps engaged on the platform. If the streaming service has dozens of millions of customers, it's easy to see how that use case can surpass the million of operations per second mark, and even the need
Mm-hmm.
that it will scale even more in the future. So I'm pretty sure you've seen multiple use cases such as this one, right, Felipe?
Yes, definitely. I have been. Some of those we have presented previously in the game changers slide, right? We spoke about the Discord, for example, and media streaming companies. We shall have some similar use cases to what you have mentioned. That's a very good one. But what I would like to do now is let's change the topic a bit because we spoke. From how ScyllaDB behaves, is able to deliver good performance numbers from a technical perspective. We briefly touched about the business perspective. And now let's switch over to costs and about the actual infrastructure that you are using on your demo. So my question is, at the beginning of our presentation, I mentioned that one of ScyllaDB's goals is to provide our users with a very aggressive TCO reduction towards their infrastructure expenditures, right? I think it is very clear by now that achieving over 1 million operations per second with single-digit milliseconds latency is impressive. But what's more impressive is the fact that you are going to demonstrate it with only a 3-node cluster, right? Can you please elaborate more on the infrastructure, the tooling that you are using, and the specific conditions covering your demo?
Absolutely, Felipe. So for this demo, I used, as previously mentioned, a 3-node cluster of i4 4x largest, which are 16 vCPUs each. And to stress it, I also use 3 nodes of R6A 8x large, and those will be running Cassandra Stress with a design workload. The worker nodes have a CPU ratio of 2 to 1 CPU on the Scylla cluster, so they're twice as big. And this is intentional, as we're using replication factor of 3, so data has a high availability. We need many CPUs on the worker nodes to fully stress a Scylla cluster of this size. This Scylla cluster setup is enough to deliver single-digit latency on the P99 for reads and writes while doing over 1 million operations per second. The workload reads mostly from cache, including recently updated data. So the latency is reflective of workload that relies heavily on cache data. Sounds reasonable, Felipe?
It does. No, it definitely does. So One of the important aspects I think it is worth mentioning to our audience is the fact that although you're going to run a demo to us, not all use cases are the same, right? Not all requirements are the same, and definitely not all technical aspects covering a workload or even a deployment are the same. For example, a specific use case may read more from disk than from memory, right? It will depend on your cache hit and miss ratio. And another use case may have a larger payload size or different access patterns than the conditions exhibited in your demo. Now, the question is, as a solution architect, you and we frequently work with a huge set of distinct requirements, right? Could you elaborate a bit on what are some of the aspects one needs to consider when they are trying to achieve their own 1 million operations per second?
Oh, for sure, Felipe. I think that the payload certainly makes a ton of difference with regards to the throughput expectations of a cluster. After all, a payload of 1 kilobyte, while the 1 million operations per second mark, means roughly 1 gigabyte per second in throughput. If the payload were larger, let's say 100 kilobytes, then the expectation of 1 million operations per second might need a completely different hardware setup. So calculating the expected throughput using operations per second and payload size is extremely important to design a system that can deliver high throughput and still keep latency single digits. The ratio of reads and writes is also very important, as both of them have different weights in the cluster. Ingesting data is extremely cheap in Scala, and reading the data is very performant. Using materialized views and indexes add overhead to writes, so it's also important to consider them while you're planning a system. And as I previously mentioned, the usage of cache is crucial to low latency. So it's important to ask, how does the application read data? Is it historical data being constantly read, or is it reading recently inserted fresh data? Are analytics processes polluting the cache? Keep in mind that the analytics application should always be designed in a way that avoids impacting your live user workload. So which can be seen at different aspects in the cluster. Live user workload cache should not be disturbed by a long-running, heavy analytics workload. CLDB's enterprise feature, workload prioritization, and CQL extension bypass cache can help in these scenarios. So I hope this clears things up, Felipe.
It does, and you also mentioned some very good aspects. Workload prioritization, I recently gave a talk about what it is. And how to easily get started with it. It's, as Guy said, an enterprise exclusive feature. You also mentioned about cache, and I kind of alluded to it as well, about cache hit and miss ratios. So ScyllaDB actually implements its own cache, and one of the things we see are essentially several organizations actually replacing their caches, such as Redis, Memcached, and others, along with ScyllaDB when they have a need for a real-time workload. Last year, we also had a webinar where we explained point by point about why we decided to have our own cache on top of ScyllaDB, and in order to completely bypass the Linux page cache, Thomas Grabiak, our distinguished engineer who worked in our cache, gave us a big deep dive through how the cache is implemented. So very good answer, Guy. And it also opens rooms for us to talk about some of ScyllaDB's specific features. Thanks for that. Now, let's move on. So, how do we get started? I mean, if I had never worked with ScyllaDB before, but I already have some experience with either DynamoDB, Cassandra, or any other NoSQL database, such as, I don't know, maybe Mongo. What do I need to know before adventuring myself? We already know that we need a distributed ScyllaDB cluster, right? Which is the what you're going to show us. We also need either an application or a benchmark tool in order to submit requests and see the performance in action, right? And my question is, what are some of the considerations needed when I'm getting started, Gui? Some of the common mistakes that you've learned from your experience, and most importantly, is there any observability monitoring tool which one can use to observe results and see how their cluster is behaving and inspect, watch out for problems throughout their journey?
Absolutely. You need a cluster running on good hardware, and if you need anything
Yeah.
performance related, don't expect a Docker cluster running your own laptop, as best as your laptop can be, to perform well. Scylla needs the best hardware you can get, and the fastest and numerous CPUs, lots of memory, and fast disks. Our recommendation for cloud instances is to look for locally attached NVMe drives, such as the i4i family on AWS, and 2 HiMem on GCP, and standard LS v3 on Azure. And of course, I picked the i4i 4X largest as they have Nitro SSDs and they're very fast CPUs, along with lots of memory. So this is what a high throughput, low latency database needs. And also, it helps the database is able to squeeze at every ounce of performance out of the hardware that you're paying for. As a benchmark tool, the go-to solution is Cassandra Stress. Cassandra Stress does allow you to design your custom user workloads using a YAML file, and it's great for complex scenarios and to run multiple queries. When you're using it to stress Scylla, make sure that the Cassandra Stress binary is provided by the Scylla Tools package is being used, as it contains the Scylla specific shardware driver for the best performance. YCSP, which is also a great tool to stress databases, including Scylla via the SQL protocol, as well as Scylla Alternator, which is our DynamoDB compatible API. Also, pick a good server to use as your stressor. Scylla's top-notch design can hardly be defeated by a stress program written in Java and running on a tiny instance. So stressing with no monitoring doesn't make sense. So if you should run it, you should definitely use Scylla monitoring to stack to collect, analyze your data throughout your whole testing. This freely available stack will grant you insight on databases and expose ton of metrics that will ease the understanding of how database performs under your different tests. The bottom line is never ever benchmark without monitoring. Right, Felipe?
Right. No, that's definitely a mistake we see people doing fairly often, right? Right. So they install the product, or maybe they, as you alluded during the beginning of your answer, they spin up a CyllaDB inside a container and they expect performance out of it. I mean, whenever you add more and more layers of indirection, there are more things that can end up hurting your performance. What else I wanted to really talk about it? Yes, we have a very good, if you never use it or got started with CyllaDB, if you go to our website and click on the get started button, you will essentially have a way to get started with an already built application in Rust, like in a few minutes, and you won't even need to use your laptop. So simply go to cylladb.com, clicking the Getting Started button at the top right corner of the page, and so you can see how you can get started. All right. Now, there's another thing, right? Because want it or not, we are technical people, we are engineers, we are solution architects, which means we are also terrible people in order to do selling. Because currently we have been talking about CyllaDB, about setting it up, and you need to set up monitoring, and you need Cassandra class and shardware drivers, blah, blah, blah. But if you are a first newcomer, all of this may seem a bit confusing to you and too complex. So if you don't want to go through the hassle of setting up your own cluster, configuring it, or managing it on your own, remember that CyllaDB also has, we also have our own DBaaS offering, CyllaDB Cloud. All right. And Guy, I think you will show to us, right?
Yep.
CyllaDB Cloud. And
Yeah.
I mean, it's very easy to get started. You can easily integrate it with a Terraform provider, which allows you to easily manage your cluster resources as you are already using, and as you are already familiar with in your own cloud environments, etc., and so on. All right, you can even get started with a free trial on ScyllaDB Cloud, so you can get a clustered up and running in a matter of minutes. All right, so now that you have seen how easy it is to get started with ScyllaDB, let's switch over to our actual demo. And that's the part where I will give control to Guilherme. So Gui, please show us your demo. And yeah, let's see how it goes.
Absolutely. So, guys, in general, I'll give you an overview on how Scylla Cloud looks like. This is the actual Scylla Cloud cluster deployments view. So this is my cluster used for this demo. It's running Scylla version 2024.1, which is our latest and greatest enterprise. It's composed of 3 node clusters. It's a broadcast type of private, so it's privately communicating through a VPC that is peered to this deployment. And I have DNS enabled, so I have DNS endpoints for each of the IP addresses, each one of the racks in the IP addresses on my deployment. We can also see the replication factor that I chose, the size of the cluster, the block that I used to deploy it, and also each IP address and service status for the nodes in general. Also the node type, so I'm not hiding anything here. It's exactly what you see. And on the top right, you have the operations per second mark. So we're currently at 1.5, just changed to 1.551 million operations per second. The storage utilization is roughly 7%, so it's a small data set. And load or CPU load is roughly at 77%. You can also hover to new cluster and spin up either a dedicated VM or a free trial. On dedicated VM, you can pick the provider that you want to use, either AWS or GCP. And if you're deploying on AWS, you can also deploy either in our own account, where you pay us for the infrastructure of it, or your AWS account through what we call BYOA, which is when the resources are deployed in your account and you pay AWS directly for the hardware. Then you can also pick which API are you using, either CQL, which is a Cassandra compatible API, or the DynamoDB compatible API. You can pick any of those two to start up and kick off a cluster, and the region that you want to deploy on. We support most of the regions that are available in AWS and GCP as well. Then you have to pick and choose your cluster or the nodes that will compose your cluster. You can pick the instance type. So let's say I want a cluster form of I4 largest, and then I can pick the number of nodes, usually in multiples of 3, because that's the default replication factor. So in this case, I can go from 3 to 6 to 9, 12, and so forth. And when I change it, it will reflect automatically in the number of operations per second sustained and peak throughput that is expected for this cluster, as well as the cost that is associated with it. Keep in mind that, as Felipe mentioned, we do have a free trial available. You have T3 micros, which are tiny, tiny instances, but still very good for you to do functional tests, smoke tests, anything that is not performance or high throughput, high disk utilization cases. So if you're just testing and seeing how Scylla behaves under certain conditions, or you just want something to be a sandbox for queries, you can use these T3 micro instances to deploy a sandbox cluster. We also have, it's not available here, but we have a free trial which allows you to pick one of the instances, a very small instances, and you can run them for 72 hours. So it's really a good test to see how a proper instance behaves under Scylla and how that performs for your workload. So you have 72 hours to just give it a go and test, see how it performs. So now that I showed you how Scylla Cloud interface looks like, let's jump right into our demo. So in this case, this is the greatest Scylla monitoring. Let me just hover back into my cluster view. So from the cluster view, you can click on monitoring and it will open a different window with the monitoring on. It's included by default, so it's always there. And you can even scrape data and export it through your own Prometheus if you want to play with the metrics. In this case, it's running 1.5 million operations per second at 77% load, CPU load. And all the average read and write, as well as the P99 for reads and writes, are all under 1 millisecond, so 634 microseconds. We can see that we're currently doing roughly 1 million operations per second for writes. So you can see that it hovers between 997 and 1 million. And for reads, we're hovering usually around 500 K ops per second. So that's a really impressive number for such a small, quote unquote, cluster. In this case, why are we able to achieve that number of operations under this very surprising and impressive latency? It's because, as we discussed during our interview, of the cache hits and misses ratio. So in this case, all the data that is being read are being read from cache, which means that data that was very recently inserted are being read back to simulate a use case. So in this case, very rarely you touch the disk and you have a higher performance, lower latency, especially for reads, and that will for sure reflect on how your P99 looks like under this type of simulation. We can also see the breakdown of disk utilization for data center. In this case, I only have a single data center, but if you had more, you could see the breakdown for each one of them, the different workload patterns, the cache hits and misses, running compactions, average disk utilization. All of that can be broken down into the DC level on this overview page. And you also have a view of the nodes in your cluster, the version that are currently running, Scylla version, and how many loads they see live, so how they are seeing each other, if there's any disconnect there, and what is their current load and streaming capabilities. So the load of the CPU load of those loads are currently at 77, 76% at CPU utilization for Scylla. So from this very overview panel, we can click on the hamburger icon on the top right and select detailed, which is the one that I have over here. And by default, it has a very bird's eye view. It starts with the cluster view of the deployment. It brings all the metrics from the cluster perspective. So if you have multiple data centers, you will see everything aggregated into a single one. If you have multiple clusters, you have different metrics for each of the clusters separated by cluster. But in this case, by cluster is not enough, neither by DC, because I only have a single DC. So let's drill down into what we call instance level. Instance level will show me metrics on the instance level, as the name suggests, and it has a very reflection of what instances are reflecting in metrics at any point in time. So we can even see exactly how it was processing 30 minutes ago for operations and latencies and whatnot. But let's not stop there, because Scylla, with its shard-aware design, also export metrics down to the shard level. So when you change the by selector to shard, it will actually allow you to view each shard in every node in your cluster. Doesn't matter how many nodes you have, how are they performing at any point in time. So in this case, we see the breakdown of CPU utilization for each one of them. It's very equilibrated, so it's very balanced, and it's working exactly as intended. We can also see the breakdown of operations per coordinator, which are the shards that are receiving the request from the driver. The reads per shard replica, or how many reads are recurring for each of the replicas, or how many replicas are being involved for each read, and writes per shard replica. Usually for best performance, this is exactly what you want to see. It's all shards being stressed or forced on the same level. They're all being very distributed. The access pattern is very distributed. There's no hotspot either for access, which is everyone trying to access or write to the same partition, nor you have a large data set which has multiple rows, millions of rows within a same partition. So this is the perfect scenario where you have multiple shards being accessed at any point in time. And then if you think about the traps that you can see when you're doing millions of operations per second, is that your cluster health is dictated by how the writes and reads are being processed, not only for the actual application, but within Scylla itself. So that's why we have the reads and write coordinator charts, which shows you foreground writes and background writes. Foreground writes being writes that are incoming from applications that are being acknowledged, but still being worked on. And before that acknowledgement, they'll be sent into foreground writes, and background writes are internal or after acknowledgement writes. The same goes for reads and writes. So in those cases, you usually want to keep a very close eye into those metrics in order to make sure that your cluster is healthy at any point in time, and especially when you're experimenting with your application. If you see that reads are increasing for foreground or either background, it probably means that your cluster is getting overloaded, or you have some other imbalance in your data modeling or data access pattern that can cause that queue to grow, and latencies will for sure spike later down the road. When we're looking at latencies, we have the operations for reads and writes per shard as well. And you can also have a number of latency down to the shard level for each of the workload groups that you're using. So as we discussed previously, we do have workload prioritization, which allows you to create multiple groups with different priorities among them. And those priorities will affect how those perform. And you also want to know exactly how is your lower priority analytics use case performing, even though it's lower priority. So Scylla will grant you the visibility of that per service level. So if you have 2 or 3 or 4 different service levels and they're pushing very different workloads, you can see exactly what they're pushing and what are the latencies for average, which are just 2 panels, 95th percentile and 99th percentile, all on the same screen. So it's really great. You can also have the background, the information on the coordinator view of timeouts and errors. So if there are any kind of timeouts or unavailable writes or reads, you can see that in this panel. Everything is healthy, so there's no data to report. That's why it says no data. You'll have a ton of metrics for replica and for cache. I think that the cache is most interesting one because it shows reads with no misses and reads with misses. This is about the cache perspective. So no misses means it hit the cache, and misses, it missed the cache, so it had to hit the disk. In this case, as I mentioned, the latency of this demo is dictated by how well it's reading from cache. And we see that it's 100% reading from cache at this point. So you can see that it's roughly 12K read operations per second for each of the shards. So they're being pushed their limits, all of them being hit from cache. And while you see very little to no, virtually no reads being missed or missing cache. You also have a breakdown of cache operations, which are the additional metrics that we have here. If it's missing rows or just partitions, if it's evicting rows or evicting partitions, if it's purging data to disk or reading data back for cache, you can see all of that in here. You also have a ton of additional metrics for materialized views, tombstones, light-rich transactions, CDC, and everything that Scylla touches will be in any of the panels. And of course, you have additional memory metrics for replica. So you see exactly how much memory each shard is using at any point in time. And you also have metrics around each of the latencies for the service level. So in the chart that I showed above, that's the general latency breakdown. But in here, you have the per group breakdown as well as sizes. So we can see here that the estimated write size message by shard, it's roughly 138 or 127 bytes. So that's the current payload of our IoT simulation use case, not only for writing, but also for reading. As we're reading it, it's roughly 88 bytes. So it's a fairly small payload, but that's impressive when you look at the overall scheme and how that reflects a general real-life scenario. And I'd like to show you as well the panel that I think it's the most interesting when you're doing anything that is CQL or Scylla related is the Scylla CQL panel. You can also access it on the hamburger icon on the top. Here you have the breakdown of, let me change it to shard. And you have the breakdown per operation. So you can see exactly how many inserts, reads, deletes, and updates each one of the shards are doing. So you can see exactly what is the workload that's being incurred onto them at any point in time. So if you faced an issue during your night, you can see, you can go back to the metrics and look at that point in time throughout any of the operations, throughout any of the CPUs, and see exactly what went wrong and when. And you can also have additional information such as number of connections per shard, client new connections, so what is the new connection creation rate, how many of those queries are using bypass cache to read directly from disk, and any other metrics that are shown as well. I think that the most useful panels for who's getting started with Scylla is the optimization dashboard, which is just below the Scylla CQL, which will have metrics for helping you achieve those best practices that we mentioned. You'll be using prepared statements, you'll be using paged queries, you'll be using token awareness drivers, you'll not be using reverse SQL reads, you'll be reducing the number of allow filtering or not using bypass cache. So all those metrics will be ticking as you are inducing those anti-patterns on your workload. And the greener you see, as you see here, the closer you are to be on a perfect scenario from those perspectives. And of course, I think that the utmost concern is, okay, if I have multiple DCs, on the same cluster, how does the query latency is impacted by the queries crossing data centers? And you can see exactly that in here, which is the breakdown of operations that cross data centers. So if you have a higher latency, you probably configure something wrong in your application and you're crossing data centers just for a single query, which you should not do. So those will also trigger a tick on those graphics as well. So going back to the general overview, I think that the number is really impressive. We targeted for 1 million operations per second and we achieved 50% more. And we still have some room to grow up in regards to the latency and the CPU utilization that we see here. I just did not push it. So we would stay at 1.5. I think it's a 50% cutoff and it's nice to show. And I think that it's really impressive to think how just 48 vCPUs on Scylla can deliver this number of operations all in parallel. So Felipe, what did you think in general?
I think I learned today that the top right icon is called a hamburger.
Yeah.
But I mean, I am biased, right? I am technically your peer, so. But no, it was a very good presentation. And what I particularly liked to see was you showing the cache panel, which essentially contains the very same metrics that you would expect from any other cache, right? Rows being evicted, rows being hits and misses from a cache, etc., and so forth. That's truly impressive. So, guys, we are almost done, and we are going to start taking questions shortly. But before that, let's take a quick poll so we can get to know you and your use case better. How much data do you have under management of your transactional database? We are going to give you some time to answer now. And while you are answering, since we are almost short on time, let me switch to the next slide. And let's talk about some other resources and upcoming events that we are going to be hosting. So before we actually dive through all the many questions, thank you guys for all those great questions you are sending. We have added some amazing content here for you to learn more about ScyllaDB. First, ScyllaDB University Live is one of our upcoming events. for learning and getting hands-on experience with ScyllaDB. We will discuss topics from the very basics up to more advanced content, algaes with labs, and instructor-led sessions. I will be there, I'll be presenting. So I would like to invite you to please attend, so I'll be there. Now, Scilla University Live is our de facto recommended learning resource for you to get up to speed really quickly, all right? In addition to it, we have also recently hosted our ScyllaDB Summit event, which included talks not only by ScyllaDB employees, but also several customers explaining how they leverage ScyllaDB across their environments. I encourage you to watch our ScyllaDB Summit on-demand content, and I would like to personally highlight the talks from Discord around insights from a production incident. People don't talk about incidents those days. Well, Discord did. And it's a very interesting talk. And I would, and also, I mean, Expedia, who walked us through their Cassandra to ScyllaDB migration journey, Digital Turbine and SADA, a great discussion on how they radically outperformed DynamoDB with ScyllaDB. All right? Now, I can see we have tons of questions. Thank you so much again for filling the poll. Let's get started. Gui, can you please take on the first question?
Sure, absolutely.
And since we asked for people to post their questions in the Q&A button, let's take those one first with respect to those people who actually followed our recommendations.
Sure, absolutely. So Vladimir asked, what are your favorite metrics when monitoring Scylla or how Scylla cluster behaves? So Vladimir, in general, the metrics that we focus on are the same metrics that are embedded into our alert manager profile. So I'm not sure if you looked at that, but we do have an alert manager set, rule set, which are set to be triggering alerts on your infrastructure whenever you cross specific thresholds. So to ensure that your cluster baseline is healthy, you would monitor for hardware issues or node failures. If you experience any sort of unexpected events, such as losing a node or having a node out of the network, for sure those metrics will make sure that your cluster is healthy at any point in time. Apart from that, you can include your own metrics if you're working on your own Scylla monitoring stack, and you can create metrics based on latency or errors, whatever you see fit for your application. That's the beauty of an open source project such as Scylla monitoring, which allows you to create not only what comes embedded with it, but a myriad of options when you're talking about picking the metrics and focusing your application. Of course, I think the general overview is to set to those metrics that are relevant to your application. Let's say you have a highly focused or user-oriented read pattern, but your writes are done by batch, maybe on an overnight job, and you're not that concerned if a write fails. So in that scenario, you would not necessarily monitor for write failures, but you will be for sure focusing on latency and possible failures for your write pattern. Okay. All right.
Thanks.
I have another
Perfect.
one from.
Right.
Can I get
take
one?
another one?
All right. Go ahead.
You can take whatever you want. Let me take this one from Marlon. So Marlon posted a link about ScyllaDB workload attributes and is asking, why is this page waiting the open source documentation? Actually, workload attributes is an open source feature. Workload prioritization is ScyllaDB's enterprise-only feature. Okay, so if you're using open source, ScyllaDB open source, and you want to use workload attributes, which again I explained in my talk, which is ScyllaDB Summit on Demand. We unfortunately don't have the time for me to speak about what it is. It will work just fine in open source. If you try to use an enterprise feature on open source, it's not going to work because it's not enabled in the code. All right. That's it. Gui, you want to take another one?
All right. So Lori asked, how do you pick multiple zones for resiliency for when AWS East goes down. So when you're talking about zones, those are zones within a region. East, let's say East 1 is a region, and East 1A, B, and C are zones. So when you're deploying Scylla Cloud, we make sure that we automatically pick different zones for your deployment, matching your replication factor. Now, when you're deploying it on your own, when you're picking where your data should be, your EC2 instance should be deployed, there's an option of which zone you would like it to go into. Usually it's tied to your subnet, so you usually have different subnets for each of the zones, but there's some different set of ways that you can do it, either through the UI or command line. So do look for those options. Scylla will if you're using the EC2 snitch, which is when Scylla automatically recognize the type of instance it is running on, and it's running on AWS, it will automatically recognize the zone and region that is running on to name it a data center as a rack. That will automatically work as soon as Scylla is installed.
Perfect.
Felipe?
Thanks, Gabe. Taking two from the same person. What is the release date for ScyllaDB 6.0? I have a project pending, and will there be any benchmarks tests of V5, ScyllaDB 5 versus ScyllaDB 6? So currently there is no release date defined. Probably, maybe, but not a commitment next quarter. Okay. ScyllaDB 6, it's a good question because it's the first release where we are going to have tablets, right? The whole idea of splitting your table into smaller fragments, which can get easily dynamically allocated to different CPUs and nodes, and distributed and get data distribution evenly across your cluster. So yeah, we are looking forward for ScyllaDB 6 as well. If you have a project pending, as you said, why don't you get started with ScyllaDB 5.4, which is the latest, and then later on you upgrade. And also with regards to your benchmark tests, we are already benchmarking ScyllaDB 6. We constantly do regression tests. We definitely want to share numbers, maybe not from a performance standpoint, but from a scalability, elasticity standpoint. I think that's what would make more sense for comparing ScyllaDB 5 versus 6 with and without tablets. But this may change, okay? And we are definitely going to share some numbers as the time comes, all right?
Okay.
Yeah.
Do you have time for one more?
We do, yes.
Okay, cool. So Vladimir also asked, there are no issues like hot partitions. So is it possible to detect them through Scylla monitoring metrics? And Vladimir, I think that's kind of reliant on your workload pattern. But whenever you're looking at the per shard metrics, you should see them as you saw during my demo. They should all be as close together as possible. If you see any outliers, especially if you're using a replication factor of 3, you would usually see 3 outliers. Then those could possibly represent a hot partition for either reading or writing. So it's a matter of picking what is the nodes that are currently facing that situation. So let's say out of 100, only 3 shards on 3 specific nodes reported a different access pattern. Then you can go into those nodes and run probabilistic tracing or top partitions in order to collect further data and train down exactly which application and queries are hitting those partitions.
Perfect. Thanks, Gui. We have one question from Praveen where he's asking if the request size, I assume he's referring to the payload size, increases, does it mean that I think we're referring to the shard, each CPU will still be able to deliver 10,000 reads/writes per second with 3 nodes replica? So as we have alluded before the actual demo part, we do acknowledge that workloads are different, and depending on your workload, you may get different numbers than what Guilherme showed here. After all, as he said and he presented, his workload is reading from the cache 100% of the time. This is not true for many workloads out there. So you may get different numbers. By how much, it will depend on your workload, which is why it's important that you test and that you benchmark your workload accordingly to your SLAs. Before we close out, this I think it just has been asked into the chat, but in any case, it's also a question across the board. Gui, if people would like to run that benchmark you've run and demonstrated to us, do you have any research to share to them?
Sure, there is a 1 million operations per second demo using IoT data that is available on our GitHub. I think the link is included on the slides, and you can use that to spin up using the Terraform API. You can spin up a Scylla cluster that matches the requirements and the accompanying AWS nodes to stress the cluster, and that will automatically also deploy Cassandra stress and make those available for usage and kick off the testing. So you can basically just run Terraform apply and wait a few minutes to go to your monitoring and see the magic happening.
Yeah, and guys, just so you know, we are running out of time, so save the link Cynthia just pasted into the chat. That's how we work here. We don't just simply show you a demo and try to hide how we make things happen. You can actually try it on your own and see the numbers for yourself. All right? All that said, guys, we are short on time. Thank you so much for attending our session today. Here are some links for you to follow up and learn more about us. And Gui, once again, thank you so much for your amazing demo. And guys, I hope to see you shortly. Bye.
Bye, everyone.